As part of polynomials, let us understand the concepts of zeros of a polynomial, remainder theorem and factor theorem. Before that, we have to know how to find the value of a polynomial. Let's say the polynomial is 5x plus 7. Right? This is a polynomial in one variable. The variable is x, and it's a linear polynomial because the power of the variable, the highest power of the variable in any term is 1. So it's a linear polynomial in one variable. We have to find the value of this polynomial given the value of the variable. Let's say the value of the variable is 0. Then what is the value of this polynomial? We use the method of substitution. Wherever the variable x appears in this polynomial, we have to substitute the value of x as the given value. In this case, it is 0. Let's put the value of x as 0 and find the value of 5x plus 7. That means I'll say 5 into 0 plus 7, that is equal to 7. This is the value of the polynomial when x is equal to 0. What is the value of this polynomial when x is equal to minus 1? It will be 5 into minus 1 plus 7. That means minus 5 plus 7, that is 2. We can find the value of this polynomial for any given value of the variable using the method of substitution. I can denote these polynomials by p of x or q of x or anything. Let's denote it by p of x. Let this be 3x square minus 2x plus 5. This is a quadratic polynomial because the highest power of the variable x is 2. It's a quadratic polynomial in one variable. That variable is x. Let's say x is given as 1. What is the value of the polynomial when x is equal to 1? That is denoted by p of 1. Substitute the value of x as 1 wherever x appears in that polynomial p of x. So that would be 3 into 1 square minus 2 into 1 plus 5. That would be 3 into 1, 3 minus 2 plus 5. That would be 6. You can find the value of this entire polynomial for any given value of the variable x. So that is the way to find the value of a polynomial. We'll also understand what is the difference between an expression and equation. We know that any polynomial is an algebraic expression. Algebraic expression is a general term. A polynomial is also an algebraic expression. Let's say I have something like 3x minus 5. This is my polynomial. And what is an equation? If I equate this expression to say 0, 3x minus 5 is equal to 0, this becomes an equation. In an equation, there is an equals to sign, there is an LHS, there is an RHS. A right hand side, a left hand side, both of them joined by the equals to sign. That is an equation. Whereas an expression, more specifically a polynomial, will be like this. We need to understand the difference between these two when we want to understand the concepts of the zeros of polynomial, remainder theorem, etc. Now, other thing that we need to know before going into those concepts is the division process. When we understood the division process for numbers, we understood it by dividing any given number by another number like this. For example, if I want to divide 28 with 4, 4 goes into 28 7 times, 4 sevens are 28. So this is giving a remainder of 0. This is called divisor. This is called dividend. Let's write it down. This is called remainder. When I divide, let's say 30 with 4, my quotient is 7 still. It goes into 30 7 times. The remainder will be 2. Whether I get a remainder of 0 or some other number, the division rule is always the same. The dividend, I'll write it here. Dividend is equal to divisor into quotient plus remainder. You can take the example that I just gave. Let's say dividend is 28, the divisor is 4. Then the quotient would be 7, remainder will be 0. If it is 30, it will be 4 into 7 plus remainder. This is the division rule for the division of numbers by another number. This is the same rule that applies to polynomials also, but then we need to understand the relationship between the divisor and the remainder. In the case of division of normal numbers, what is the relationship between the divisor and the remainder? You can say that the remainder is always less than divisor. For example, my divisor is 4. If the divisor is 4, what are the possible values of the remainder? Divisor is equal to 4. What are the possible values of the remainder? 0, 1, 2, 3. The remainder can't be 4 or more than 4. So I can say that the remainder is always less than the divisor. But in case of division of a polynomial by another polynomial, we don't compare the divisor polynomial and the remainder polynomial directly like this. We compare the degrees of the remainder polynomial and the divisor polynomial. We'll understand that in a little more detail when we actually talk about the remainder theorem. But we have to firstly understand how to find the value of the polynomial given a value of the variable. What is the difference between an expression and equation? And this dividend rule as it is applied to the polynomials. Now we have to understand zeros of a polynomial. What is the zero of a polynomial? Let's say my polynomial is p of x is equal to x minus 2. Is a linear polynomial in one variable. What is the zero of this polynomial? The zero of a polynomial is that value of the variable that makes the entire polynomial's value 0. The value of the variable that makes the entire polynomial's value 0. So how do I find that value of the variable that makes the entire polynomial's value 0? The polynomial's value being 0 means, let's set this in this example, let's set this value of the polynomial to 0. This is the condition. When I have to find the value of this x that makes this entire polynomial's value 0. So I equate the polynomial to 0, which means I equate x minus 2 to 0. Then I get the value of x as 2. So this is the value of the variable that makes the entire polynomial's value to 0. What are the other values of the variable? I can put x equal to 0 and check the value of the polynomial. I can put x is equal to minus 1. I can check the value of the polynomial. I can put x equal to 1. I can check the value of the polynomial. In all the other cases, the value of the polynomial will be any other value other than 0. Only when x is substituted as 2 in that polynomial, you get a value of the polynomial as 0. So this is called the zero of the polynomial. In another example, let's say my polynomial is x square minus 5x plus 6. So what are the zeros of this polynomial? To find the zeros of this polynomial, it's a quadratic polynomial in x. To find the zeros of this polynomial, I will set the polynomial itself to 0 because that is the condition, right? I have to find the value of this x such that that value of the variable x makes the entire polynomial's value 0. So I have to set this polynomial's value to 0. I'm getting an equation that I have to solve. From an expression like this, I'm converting it into an equation by setting it to 0 to get the values of x. Those values of x would be the zeros of this polynomial. So if I factorize this, what do I get? X minus 3 into x minus 2, that's equal to 0, which means that x minus 3 is equal to 0 or x minus 2 is equal to 0. That implies x is equal to 3 or x is equal to 2. So the zeros of the given polynomial p of x, zeros are 2, 3. You have to observe that the zeros of this polynomial 2, 3 are nothing but the solutions to this equation that you get by setting p of x to 0. So I can write this definition also as the zeros of the polynomial are nothing but solutions or roots of the equation that you get by setting the polynomial equal to 0. Both are the same. Zeros of a polynomial are nothing but the values of the variable that make the polynomial's value 0, or the solutions or roots that you get by solving the equation by setting the polynomial to 0. Okay, so we have understood what are the zeros of a polynomial. Next, what is the remainder theorem? When a polynomial p of x of degree greater than or equal to 1 is divided by x minus a linear polynomial where a is any real number, the remainder, it only talks about the remainder that you get. The remainder is p of a. What is p of a? P of a is the value of the polynomial, this polynomial p of x, when you substitute the value of x as a. So what is this remainder theorem saying? It's saying that when my dividend is p of x, that is when p of x is divided by x minus a, which is the divisor, I get some quotient. I can denote that quotient polynomial by q of x, and I get a remainder which is nothing but p of a. This is what it is saying, right? If I have to prove this, where do I start? In general, I know the division rule for polynomials as this, which is the same as the division rule for normal numbers division. The dividend is equal to the divisor into quotient plus remainder. Let's assume that the remainder is another polynomial in x, right? Finally, we have to prove that this is not p of a. Let's see how to do that. But what do we know here? The relationship between the divisor polynomial and the remainder polynomial. What we can say is let's say that this is the equation 1. Degree of remainder polynomial is certainly less than degree of the divisor polynomial, which is x minus a. What is the degree of this linear polynomial? 1. I know this is a linear polynomial. X minus a is a linear polynomial of degree 1. So that means I can say that the degree of the remainder polynomial is what then? If it is less than 1, it has to be 0. Therefore, I've come to the conclusion that degree of the remainder polynomial is 0, which means that it is not a polynomial in x, but it's some number, right? Therefore, I can write this equation 1 as p of x is equal to x minus a into q of x plus, let's denote that by r instead of r of x, because I now know that it's just a number where r is some real number. Now this, I can find the value of p of x now for any value of x. Let's say I'll find the value of this polynomial when x is equal to a. Let's say I substitute x as a. What do I get here? A minus a into qx. Also I can substitute as a now plus r. That implies what? R is equal to, this entire thing vanishes, right? A minus a is 0. So therefore r is equal to p of a. Therefore my remainder theorem is proved, right? So I proved that this remainder is nothing but p of a. So remainder theorem is now done. Now coming to factor theorem. Factor theorem is nothing but an extension of the remainder theorem. What does it say? Now, if the polynomial p of x is divided by a linear polynomial x minus a, and we know that from the remainder theorem, the remainder is p of a. If that remainder happens to be 0, then I can say that x minus a is a factor of the polynomial p of x. That's the meaning of a factor, right? For example, when I say 28 is equal to 4 into 7, I say that 4 is a factor, 7 is a factor. But because 4 can divide 28 completely, 7 can divide 28 completely without leaving any remainder. That is, when remainder is 0 in a division process, we say that these divisors are all factors of the given dividend. Similarly with polynomials also, when I have a polynomial p of x that I'm dividing with another polynomial, linear polynomial, say x minus a, and I get some quotient, I don't care about that quotient. If the remainder is 0, then I say that this x minus a is a factor of this p of x, because then p of x will become equal to x minus a into q of x plus the remainder 0. This is the essence of factor theorem, which is just an extension of the remainder theorem. Let's write down the factor theorem. If the remainder is 0 when p of x is divided by x minus a, then x minus a is a factor of p of x, right, where a is any real number. So from remainder theorem, what do we know? P of x is equal to x minus a into q of x plus r. Now factor theorem is giving us the fact that this remainder is 0. Let's put that value of r as 0. Therefore p of x is equal to x minus a. This is from remainder theorem. In fact, this is not r. I can write that as p of a. Now that I know the remainder is p of a, so I can write this now as x minus a into plus 0. That implies p of x. This is what the factor theorem is stating, that remainder is 0. Now I have to come to the conclusion that x minus a is a factor of this. So if I can write p of x as a product of this and this, I can clearly say that x minus a is a factor of p of x. This is the factor theorem. Let's do some examples in the next video.